Hey everybody, this is Larry. This is me going with Q4 of the recent bi-weekly contest 44. 70 count ways to make away with product. Um, so actually, oh yeah, hit the like button, hit the subscribe button, join me on Discord. So I didn't solve this during the contest. I'll have a link below so that you can watch me solve it during the contest. But I jumped around between this problem and Q3 during the contest. I couldn't. I think if I had full time dedicated to this, I might have been able to solve it, but I was just too tired. And to be honest, but actually, I don't know if that's true. I already lied, maybe, because this is a very mathy, very combinatorial. Maybe not very, but that's the hardest part about it. And maybe modular inverse if you need that. But yeah, so basically the prerequisite, and it's okay if you don't get this, and because well, of course I'm going to say that because I didn't get it, but the two big components that you need to be good at, or at least above average at or whatever, to solve this problem. One is a little bit of number theory, at least the way that I do it. You need to know what a modular inverse is, and if you don't know that, then try to figure that out, because I'm not gonna get into that much because it'll make for a very long video, and but I'll go over it very briefly, but I'm not gonna go over the explanation. And then the second part is combinatorics, which will go over the intuition and the visualization, but it is hard. So like I said, I didn't get it, even though I got most of this problem during the contest. I was missing one observation about combinatorics that I think, to be honest, if you're experiencing in solving combinatorial problems, this actually should be straightforward, but I wasn't. So I was. The last time I took a combinatorics class was like 20 years ago, so I think I was just a little bit out of shape to kind of because once you have the good mental model for combinatorics on counting things, the code is actually much easier. And for me, I just have an incorrect or like I had a way to count them, but it was double counting duplicates for factors, which we'll go over in a second. So I just want to give you some background about my thought process during the contest in case you find it interesting. If not, then I don't know what to tell you. But okay, so yeah, so basically you have all these queries so that you have to be able to do them fast enough. Otherwise, it's going to time out. That's the big risk. And you look at the constraints, or I did. You have 10 to the fourth number of queries, and each of these numbers can go up to 10 to the fourth, which is 10,000. So the obvious statement is that you can't even do n times k, because 10,000 times 10,000 is too slow. 10 to the eighth is going to be too slow. And you also have q, so that definitely is going to time things out. So what I did is, well, first is I used a sieve of I never pronounced it right, so I just used a sieve of error. Actually, let me check on the spelling as well, because I am not good at it. But yeah, this is what I would Google for if you need to. And I think this is, I mean, I should have mentioned this as a prerequisite, I suppose. But yeah, but basically using the sieve, though I would also say that from what people told me afterwards, you actually don't need to do it, because you don't need to do the sieve, because given these number of queries, going up to log n is fast enough, because it's just 10 to the fourth times 10 to the 10 to the second for the square root, which is 10 to the sixth, which is fast enough. But this is going to be faster, but apparently the more brute force way is fast enough during the contest, is my understanding. But yeah, so basically this is how I did the sieve. Here I just get the max n and I times it by 2. Actually, I don't know why. Well, I times it by 2 just in case of all the numbers. But yeah, well, okay, because I later do it for the factorial. That's why. but this is standard CIF. Definitely get familiar with it. But basically, this gets you the smallest prime factor that is with respect to a number, and then we can reconstruct the factors by one at a time by dividing it by the smallest prime factor. So this is basically how we get the factorization of the number, and we kind of get it in a CIF. And again, the key part is noting that n goes up to 10 to the 5th. So it's not, or sorry, 10 to the 4th. So the numbers are not that big, right? So you could definitely use the CIF because it takes about n log n, which for 10 to the 4th, it's going to be fast enough. The other key part to note, though, is that, and during the contest, I actually did write a for loop to kind of confirm this, is that for 10 to the 4th, the biggest factor, the most number that you're going to have is 13 factors, 13 prime factors before it goes to go to 1. In retrospect, actually, it's a little bit more obvious, but I ran a for loop, and the reason why it's obvious is because the most prime factors that you can have as a decomposition is just log of n, which is basically if a number have, k2s, that's the number of the most number of factors that you have, or prime factors that you can have for that number. Okay. Here, and also let me rename this as choose. There are also libraries for choose, but I wanted to make sure doing it this way so that I can do it in constant time already with some pre-processing. Otherwise, this would take all of Box's time if you use a library function. So what is this doing here? This is actually very standard code for competitive programming. It's a little bit why I don't like this problem, because it's a little bit too much competitive programming. I don't think, to be honest, I don't think modular inverse should be on interviews at all. Whether you agree or not, that's up to you. But basically, as I said, you need to know the modular inverse, and the idea behind here is that, okay, so, and this is kind of standard, hopefully, I hope this is understandable, but basically we have boxes, and we want to put, numbers in the boxes, count the number of ways to put numbers in the boxes, right? And of course, if you know the literature, this is just going to be choice. This is literally choose of numbers, which is equal to boxes factorial over numbers factorial times boxes minus numbers factorial, right? So this is standard E. I don't want to explain this because, like I said, this is a prerequisite. I'll look up stars and bars, I think it's called, just to kind of get an intuition on this proof. But I wasn't able to. I mean, I got this during the contest as well, but yeah, and so the modular inverse allow us to kind of do. The annoying part about this problem is that there's a big mod factor, and because of this mod factor, in Python you could maybe get away without it, but because again, it only goes up to 13, but maybe not. Actually, I don't know if you can, but yeah, but basically this is writing the inverse of this is just 1 over f of index under mod. So basically what this is saying is boxes factorial times 1 over numbers factorial times 1 over boxes minus numbers factorial, which is the same as this thing. So this is basically how we have this function. Again, I went over it very briefly because I want to say standard competitive programming. It's not the interesting part for me. So, but the hard part of this problem, of course, is also putting these individual pieces together. So I don't want to make it sound like this is easy, but these individual parts I don't want to go over too much because, like I said, for me, it's not the interesting part, but also there are a lot of videos to go over each of these components. So I don't want to go over it that much. Okay, so then here's what I consider the trickiest part, which is what I was not able to do during the contest, which is that, okay, so let's say you have, let's say you have 2 times 2 times 3 times 3 times, okay, something like that, right? So this is obviously, you go to, let's see, let's just, this is 180, right? I just used the calculator. And so then now, so the way that I was thinking about it initially, which is wrong, was just, okay, now we have 5 numbers, we can put 5, given that in the problem you have n boxes. I actually mixed up my notation, so kind of ignore that. The code is a little bit funky there. But basically, because I mixed up K and N in the contest, but basically here, you have 5 prime factors. So my initial thought was, okay, now we have, say, I use K here, but I think K is mixed up. So let's actually swap it back to how it's defined in the problem. So we have n boxes. So my initial thought was just, okay, is n choose 5 or something like that, right? Except for that each box have at least 1 number or something like that. So I was playing around with different concepts around that for a while until later on I realized that I was not, or I was double counting, like if I want to get 6, the number 6 in one of the, because I was basically dynamic programming on one box at a time. But if the first box had 6, I double count because it could use a 2 from here or this 2, but I don't differentiate them, so that's why I got the wrong answer. So the right way to do about it, it turns out, is looking at the frequency map. Basically, for each unique prime factor, so instead of just say 5 prime factors, we break it down to 2 to the 2, 3 to the 2, and 5 to the 1, I suppose. And you still have n boxes, right? And then now we look at each prime factor at a time. So let's say for this we have 6 boxes, and of course initially we make all the boxes 1. At least mentally, we don't actually do anything, but this is just for visualization. We make all of these 1 so that, but what that means is that the boxes can be empty with respect to the numbers, right? That means that, like, it's okay with none of these numbers fit in any of the, like, these numbers could all go into the last box, and it's okay because we have 1 as a pattern. So okay, so that said, we look at each prime factor at a time, and then it becomes much more straightforward in that, okay, let's say we have the number 2, right? And then we could put it in any of these 2 ways independently. You could look at them as, like I said, stars and bars, or just different bars, but it turns out they're independent problems because now, with 6 boxes, you could say there's 5 dividers, I want to say 1, 2, 3, 4, 5. And now just looking at the stars again, so and this is just putting in the number of ways to put stars in between these bars. And again, if and the way to solve this problem, to count this, is just equal to the stars and bars, which is equal to this choice thing. Again, I'm not going to go into this part too deeply, because this part in particular, after you break this down, is a standard E problem. The tricky thing is noting that each of these prime factors, you could actually do them independently of each other and then multiply them because they are independent. Because basically you have different stars, if you want to call it that. Let's just call them A's maybe. And then now you could put B's anywhere you want. So we still have 5 dividers. We could put B's wherever we like, and because we can put these 2 things independent of each other, just adding the spaces, independent of each other, we can just multiply them, and we repeat again for C. which is in this case the 5s, right? So that's basically the idea. And of course, with the stars and bars, just to be clear, I drew it this way. You can actually have multiple things in the same one. So this is a possible answer as well. And again, these are all independent of each other. So this is how we come up with this, which is that we take the product of each of the individual stars and bars problem, and then we mod them, and then that's the answer for that answer, right? And again, I did not get this during the contest, so don't feel so bad if you don't either. All these components, the cool thing for me, and I actually like this problem a lot, even though I didn't get it, I wish I did, is that it taught me how to do combinatorics in this way. I actually didn't, that's why I didn't, I just wasn't able to kind of think about how to dedupe this. And with combinatorics, usually once you're able to get the correct visualization and listing them in a correct way, then you are able to find the answer pretty straightforward. I mean, this code is actually pretty, once you have all the things set up, this code is pretty straightforward. And once you have the understanding, it becomes correct. And again, obviously, we don't forget the mod. But yeah, so the idea is, so the question is, what is the complexity of this? Again, so, this is n log n for the biggest n. Sorry, for n is the biggest number in queries. This is going to be n log n. So let's actually define this real quick. So let's say n is the max number in queries, and q is the number of queries. So yeah, so this is going to be n log n, and this is standard Civ stuff. Not going to prove this part because the proof is actually a little bit tricky. Yeah, and for this happens for each query, so we'll talk about that later. But again, like I said, this is at most log n, because in the worst case, it's all 2s, so you divide it by 2 every time, which is obviously log n, right? So yeah, so this is log n as well. So so here, this is log n. And here this is linear, because this is just pre-caching. So this is linear. This is O of n. This is O of n. I guess n is not technically linear, but yeah, but these are both O of n's, and this is O of 1 once we have these numbers, assuming assuming some the multiplication is relatively constant, and because we mod it very often, it's close enough. And I would also say that if you're watching from another language, this will actually overflow. It's just that in Python, it's okay to overflow a little bit because you just pay for it in performance, but because we mod it later, it's okay. But if you're in another language, you may need to kind of be careful how you handle these as well. And again, this is the modular inverse in Python, which makes it a little bit easier to write. In another language, is a little bit of a mess, so sorry about that. But yeah, but in terms of complexity, this is O of n, and of course O of n space here as well, and also O of n here for the Civ, which I forgot to mention. In the answer, this is going to be, then q queries, as we said. So that in terms of space, because of the answer array, this is going to be O of n plus q space. In terms of time, this, like I said, this getting the factors would take log n time in the worst case, and then for each one we, because this is also log n, because they're at most log n entries. So this is for each one. This is constant, so this is going to also take log n time, because this is a log n loop. So this entire thing, because this entire thing is log n, this is going to be q. O of q log n is the time complexity for this algorithm. Yeah, and we go through it again, but this is linear in the size of the log n, so this is log n as well. Yeah, that's all I have for this problem. Usually I I will append the well, let me, I don't know, feel free to pause. I'm gonna make this a little bit smaller so you'd see in one screen relatively. Maybe this is still a little bit tricky to see, but I'm gonna talk while I scroll down so you could kind of see the code. But yeah, usually I will, show the video of me solving the contest, and I was way close, but I wait to the end. I'm just gonna link it to the contest video below, so check that out if you want. I think this is relatively clean code. Let me know if you disagree. But yeah, there are a lot of things here as well. So I'm gonna let you pause here, and then also let you pause here. I think this is barely fit into 2 screens. That's why I had to kind of be sure. Yeah, let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think. I really enjoyed this problem. I wish I was better about it during the contest. I got most of it. It's just that I got really confused about how to dedupe it during the contest. Well, but I did learn how to do it, so it is great. Because I might have learned it when I was younger, but that was too long ago. So I don't. Yeah, it's just really out of shape for me, if nothing else. That's all I have for this problem. I will see you next problem, and later.